The future of AI and autonomous spacecraft. For decades, our explorers of the cosmos have been lone wolves, sent out on these epic solitary journeys, separated from us by an ocean of time and space. But that's all starting to change. We're entering a new age of exploration, one where our spacecraft don't just operate as individuals, but as a single intelligent pack. This is the story of how AI swarms are learning to think for themselves, making decisions millions of miles from home, and completely rewriting the rules of our journey to the stars. The Lonely Explorer. Ever since we started sending probes into deep space, we've been up against a universal speed limit, the speed of light. Take the Voyager probes. They're so far away now that sending a command and getting a reply takes almost 2 full days. They're brilliant machines, but they're basically operating in the past, following instructions from an Earth that's already moved on. This time lag is the ultimate bottleneck. It means our spacecraft can't react to anything sudden or unexpected. A fleeting plume of gas from an icy moon? A weird reading in a magnetic field? By the time we on Earth even see it, the moment is long gone. We've essentially been exploring the universe through a keyhole, able to peek, but not to react. This has forced our missions to be incredibly conservative, planned down to the last second with almost no room for improvisation. So what if our explorers could think for themselves? The dawn of intelligence. The first hints of a solution showed up on Mars. Rovers like Curiosity and Perseverance aren't just remote-controlled buggies, they're pioneers in robotics independence. NASA engineers gave them their own artificial intelligence, letting them navigate the tricky Martian landscape all by themselves. Using systems like AutoNav, the rovers can look at the path ahead, spot hazards like sharp rocks or steep dunes, and figure out the safest way forward, without waiting for instructions from Earth. This onboard brain is what lets them cover so much ground and make discoveries at a pace that would be impossible with a human driver holding a joystick millions of miles away. AI is also a game changer for processing the mountains of data our missions send back. Algorithms like Aegis can sift through images, identify scientifically interesting targets, and aim the rover's instruments automatically, finding patterns and anomalies that a human might miss entirely. So we've given a single machine a mind of its own. What's the next big leap? The intelligent swarm. The next leap is going from a single smart robot to a whole team of them, a collective consciousness. Seriously. Imagine not one spacecraft, but dozens, maybe even hundreds, all working together as one coordinated unit. This isn't sci-fi anymore, it's the beginning of the AI swarm era. NASA is already making it happen with its Starling mission. This mission uses a group of 4 small CubeSats to test out autonomous swarm tech. In recent tests, the swarm was tasked with studying Earth's ionosphere, and the spacecraft decided among themselves what science to do, prioritizing observations and coordinating their positions to get the best data, all without a pre-written plan from the ground. The advantages here are huge. First, you get incredible resilience. If one satellite in a swarm fails, the mission isn't over. The others just adapt and pick up the slack. Second, they can collaborate. A swarm can specialize tasks. One spacecraft might act as the scout, scanning for interesting targets, while another with a high-res camera moves in for a closer look. And finally, swarms can explore on a massive scale. They can spread out to map an entire asteroid belt at once, or build a 3D model of a planet's magnetic field from multiple points in space, giving us a level of detail we've only dreamed of. The unseen challenges. Of course, handing over the controls to a machine millions of miles from home comes with some pretty big challenges. The biggest one? Trust. For any of this to work, we have to be confident that the AI is going to make good decisions. That's why developing explainable AI is so important. We need to understand why the swarm is making the choices it is. Engineers are working on building robust systems that can not only make smart decisions but also manage their own power, dodge collisions, and even predict and prevent their own failures. This isn't just a technical puzzle, it's an ethical one. It forces us to ask, where do we draw the line, and what are the boundaries of machine intelligence in our search for knowledge? CTANAMP. Conclusion. From the lone wolves of the past to the intelligent packs of the future, space exploration is changing in a fundamental way. AI swarms represent a future where our ability to explore isn't constantly held back by the time it takes to send a message across the solar system. The only limit is our own ambition. We're on the verge of launching not just smarter spacecraft, but true robotic explorers, able to adapt, learn, and discover things in ways we're just beginning to imagine. A new era of exploration is here, one where humanity and artificial intelligence team up to unlock the secrets of the universe. If you want to keep exploring what's next in space, make sure you like this video, subscribe, and join the journey. Stay curious.